Hello, my name is Victoria, and this video is for a project for my math class for my elementary education major. For my project, I created a couch made out of trapezoidal prisms. My clients have a small 10-foot by 11-foot living room, which equals a total of 110 square feet of living space. They did not want to compromise on their design, but they wanted something functional that would fit in their space and not take up the entire space. They also wanted something where every single person in their house, they are a 3-member household, could have a unique design. In order to make best use of the client's small space, I chose to use the trapezoid. I did this because while it still has the functionality of the rectangular couch design, it allows for cut corners, in a literal and figurative sense, that allows for more use of the space. You can see the design in this image. The design is made up of multiple trapezoidal prisms of various sizes. 1 larger one, 3 medium-sized ones, and 3 small ones for the seat cushions. Following the design, I created the dimensions and located the formulas for the relevant surface area and volume calculations. The surface area was found by finding the surface area of each of the individual trapezoidal prisms and then added together at the end. The formula is as follows. LSA, which is the perimeter of the base, which in this case was rectangular, so you add up all the dimensions of the base, times A plus B, which is base 1 plus base 2, and A plus B divided by 2. So in total, this is the formula for the surface area of each individual trapezoidal prism, which is LSA multiplied by A plus B over 2. The calculations done in full were added together at the end. For the volume of the trapezoidal prisms, the formula is as follows. The volume for the trapezoidal prisms is length times height multiplied by base 1 plus base 2 divided by 2. So it's similar to the surface area formula, but it is different in that instead of having the perimeter of the base, we have the area of the base that we are multiplying by. The dimensions that were used in this case are different for each size trapezoidal prism because there are 3 different sizes. For the large trapezoidal prism, the height was 1.5 inches, which would be 1.5 feet respectively. For the medium trapezoidal prism, the height was 1.75 inches, or 1.75 feet respectively, and for the smallest trapezoidal prisms, the height was 0.75 inches, or 0.75 feet respectively, because in this scale, 1 inch is going to represent 1 foot. Here are the total heights for all 3 of the prisms. The bases also differ between prisms. For the big prisms, the bases are going to be 5 inches, and 3 inches, 5 feet, 3 feet respectively. For the medium prism, they're going to be 3 feet and 1 foot, and for the smallest prism, they're going to be 2 and 1. These are the lengths of the bases. Now, after that, we also need to know the length of each of the trapezoidal prisms so that we can calculate both the volume and the surface area. For the largest prism, the length is 1.8. For the medium, it is 0.5. And for the smallest, it is also 0.5. The following are the lengths for all of the trapezoidal prisms. So after you had all those calculations, all those dimensions, you would then plug them back into the formulas that I showed you in the beginning, the surface area and volume formulas, and you would know the total aspect of what you're going to be dealing with, and I was able to give that to my clients. There was also a scale model created so that the clients could see how in 3 dimensions their couch would look. What you can see, the scale model, is being enjoyed by my little friends right here. No copyright intended. Little toys you can get at Dollar Tree. But here's my little couch with my 3 trapezoidal prism top cushions, my 3 trapezoidal prism medium cushions, and my 1 large trapezoidal prism base. So the couch is sitting on something and you're not just sitting on the floor covered with cushions, because then you could just use pillows. See, it is a round design to make for functional use of space, and the corners are cut so that you're not worrying about, you can't put a table here, things of that nature, to make use of the client's small space. This project was much more difficult than I was expecting it to be. Because when I first started, I had all these amazing ideas. I was like, this is going to be awesome. And then I realized, I have to make this 3-dimensional. Couches can't be 2-dimensional, because then you couldn't sit on them and they'd be drawings. So there isn't really much purpose to having a 2-dimensional couch, especially for my client, who would probably not be very happy. So I had to start from scratch, go back to 3-dimensional, and I finally came up with a design, and then I realized I have to make it. I had a lot of trouble trying to decide what to make the couch with. In the example we were given, it was wooden blocks, but I couldn't really find anything for a trapezoidal prism because it's not a very common shape. Normal prisms, pyramids, hexagonal prisms even, they're more common than a trapezoidal prism, which is very... It was also hard to find formulas for it as well because it's not really a thing. So I had to do a lot of digging in order to find formulas that work to calculate the surface area and volume of a trapezoidal prism. But, however, I think it works well, and I'm really happy that I challenged myself and did something that a lot of other people wouldn't have done, because it will work in my client's space. And with this design, I have colors here, but you can customize each of the seats, and there's 3 seats, 1 per each member of their household. This is relevant to my profession because when working with kids, you need to have hands-on activities in order to demonstrate concepts of geometry. What I've been talking about are all geometry and algebraic concepts. Equations, solving equations, plugging into formulas, working with shapes are all geometric and algebraic concepts, like I said before. And so these are really important for kids, but a lot of times, like I saw, when you just hand them a formula, it's complicated and hard to work with. So in order to help kids work with these things, we need to be able to make scale models, to make drawings, and that's something that I first need to practice myself because I didn't do that a lot growing up, especially in school. My responsibility as a teacher is to know how to do these things so that when I get into my classroom, I'm not just handing kids formulas. I'm giving them ideas, I'm giving them projects, I'm letting them work with their own problems and work through them like I did with mine. We're using problem-based learning, we're using hands-on learning, we're using creative thinking, and we're using all these skills that students are now expected to have. Right. Thank you so much for taking the time to listen to this. I hope you enjoyed it. Have a nice day.